Okay, today we're going to talk about two things. First off, we're going to talk about simplifying radicals again. Just there's another caveat that I needed to show you about that. And then we're going to talk about adding and subtracting radicals. So the first one, I don't have my main book at home, so your TOC should be Simplifying Radicals 2 and page 16 for that. So go ahead and put that into your notebook. And we need to talk about the coefficient of the radical. Many people just consider this the number in front of the radical. So a number outside of the radical that indicates how many times the radical exists. It acts similar to a number in front of a variable. So some examples of that. Right, we know that 3x is equal to x plus x plus x. We also know that, say, 1a is the same as a, right? So if we don't see a number in front of the radical, it is assumed to be 1. Okay, so what does that mean? Say we have 3 radical 2. What we're actually saying is that, first off, it's the same thing as 3 times radical 2. So just like when we see with a variable, we're not required to put a multiplication sign in between the coefficient, the number in front of a variable, and the variable. When two things sit next to each other in mathematics, it's assumed that they're multiplying by each other. And then it's telling us that there are 3 radical 2's. In other words, this would also be equal to radical 2 plus radical 2 plus radical 2, because we'd have 1, 1, and 1. If you have something like 3 radical 18, right, we'd have to look to simplify that. And if we did, we would take a 3 out of the radical, leaving behind a 2. So now that we've brought another factor out, these two things multiply, and this becomes 9 radical 2. Right, so if we're going to go through the same process as what we did for just simplifying a radical, we looked at 2 radical 72. I would take 72 and I would do that upside down birthday cake. So 2 goes into 72, 36. Now, if I'm using perfect number factorization, I could stop here because I know 36 is a perfect number. If I keep on going, right, just keep on going all the way to the end there, I could see that I have a set of 2's that would come out and a set of 3's, leaving behind the 2. I already have a 2 outside. So I keep that 2 and it just multiplies by the factors that I'm taking out. So I'd wind up with 12 radical 2, because the 2 outside already tells you that essentially radical 72 exists twice. Okay, so that's the second part. What I just wanted to show you guys what we would do if we already have something outside of the radical. So the second thing we're going to talk about today, so go ahead and turn the page, is addition and subtraction of radicals. You might want to enter that in your TOC on page 17. Okay, we're going to draw a table to help us out. So we're going to have our step or rule. Okay, so step 1. When we're adding and subtracting, we're going to simplify each radical term. If possible. And the if possible is really just telling us, like, we may have some radicals that are already in simplified form, so we can't simplify them any further. Step 2 is if the index number and radicand are identical, the radicals are considered alike. At which point we're going to add or subtract, whatever it's telling us to do, the coefficients, right? What we consider the outside numbers, and keep the radical, right? Or the same radicand. So similar to when we think about adding or subtracting like terms, in order to be alike, the radicals have to have the same index number and the same exact radicand. So let's do some examples of what that would look like. Oh, and of course, the last step, the last part, is we're going to have our answer. I'm going to put this down here now, radicand, so we can just go straight through. So one example would be 3 radical 2 plus 4 radical 2. So I look at each one. 2 is as low as you can go, and nothing else can come out of this radical. 2 over here, nothing else can come out. So I don't actually have to simplify. They're already simplified. Then I would look and see. They both are square roots, and they both have radicands of 2. So they are identical radical radicands. So what I'm going to do is I'm going to take the numbers in front, 3 and adding 4, because it's an addition sign, and put them together. When I do that, 3 plus 4 is going to give me 7 radical 2. Right? Because remember, if this means to write it out in expanded form would look like radical 2 plus radical 2 plus radical 2. And the second one would look like radical 2 plus radical 2 plus radical 2 plus radical 2. Then altogether, I have 7 radical 2's that exist. Okay, what would that look like if we have something that isn't all the way simplified? So say I have 4 radical 18 minus radical 2. Well, 18, of course, I'd do a birthday cake, and I would get 2, 9, 3, 3, 3, 1. So a 3 is going to be able to come out. So 4 times 3, radical 2, minus radical 2. So I'm left with 12 radical 2 minus radical 2. Now, I don't see a number here, but I assume it to be 1. So that means I'm going to put 12 minus 1 together because they're both square roots and they both have the radicand of 2 times radical 2. And 12 minus 1 would be 11 radical 2. Thought I would have one more room in the column. We'll do the next example down below. Say we're given 2 radical 16 plus radical 3 minus 5 radical 27. So radical 16, the square root of 16 is 4. 4 times 2, right? Radical 3 is as simplified as it can be. And 27, let's see, I would have a 3, 3, 3, and 1. So 1, 3 is going to, a set of 3 is going to create 1 outside, and 1, 3 is going to be left inside. I already have a 5, so 5 times 3, radical 3. 2 times 4 is 8, radical 3, minus 15, radical 3. So the 8 doesn't have a radical. It's not like the other two terms. Can't be added to it, can't be subtracted to it. It's just 8 by itself. And then this has a coefficient of 1, minus 15. You'll notice the rules of integers are still applying. I don't make that 15 minus 1. It's 1 minus 15. So I wind up with 8 minus 14, radical 3. My final answer. So it's pretty straightforward. I mean, if you know how to add together terms with variables, that's what you're doing here. Just first you have to simplify the variables like we learned in the previous thing. Now, if we had variables included, it's still the same, right? So say we had the same exact question, but it was 2c radical 16 plus radical 3d minus 5 radical 27d. Well, the 4 is still going to come out here. The 3d is still going to stay inside. It can't be simplified any further. And this is still going to produce a 3 to come out and a 3 and a d to stay in. So I end up with 8c plus radical 3d minus 15 radical 3d. So these two, same exact radicals, so I'm going to be able to add those together. So 8c minus 14 radical 3d. Like that would be my final answer. And we'll do some more examples in class, and we'll build some in that have variables so we can see that as well. And that is how you add or subtract radicals.